Okay, my name's Kevlin, Henney. I'm not hiring. I know, I'm sorry. Okay, so agility does not equal speed. This is an important emphasis because there are many conversations where you can do a simple word substitution. Those are quite fun. What's this person actually saying? And in many cases, you can replace the word agile, or agility, or scrum, or any of the practices with the word speed, or fast, or whatever. It's just like, do you know what? I think there's a little more to it. So, my background, I don't know, let me think. I'm kind of known for this thing. I edited a few years ago, 97 Things Every Program Should Know. I care very much about the code and the practices around it. And the bigger picture. I have a background in the patents community, and one of the things that the patents community taught me was look at things carefully. Look beyond the surface of what people are doing. Try and understand why. Also try and understand why things don't work, just as much as why they might work. Understand their applicability. This is important because I think a lot of people copy the surface, but not the depth of what is referred to as agile. So, let me think, what else do I do? I like taking pictures of books. I'm not quite good at it. Books are easier than people. They never close their eyes at the wrong moments, they never give you the wrong expression. But occasionally, I like taking the opportunity. This comes through the door, and my wife says, "Oh, what is it?" I have no idea, but I'm going to take a photograph before we open it up. And so let's start talking about what we mean by Agile. And there's certainly plenty of blogs out there that might help us. So I'm kind of interested in where these words come from. As a side point, I quite like language, and it turns out that Agile comes from the Latin, agere, which means it's one of the many words for doing. To do is a doing thing. Earlier in English, it was also known as Agilius, which is a great word. If you haven't got a company, if you haven't taken out that domain name, do it. Every other word in the English language has been taken. So, what do we mean by it? We mean a couple of things. Able to move quickly and easily. But to listen to some people, it's just that. It's about speed. And that just recalls the early 90s. Rapid application development. Again, the word rapid is just a substitute for speed. And we've somehow reduced an idea that's a little more sophisticated to something that's a little flatter, a little less interesting. So this is really all about time. And there's a kind of classic quote from Blaise Pascal. I've made this letter longer than usual because I have not had the time to make it shorter. There's a notion about quality. Now sometimes I've seen this variously misattributed to many people. The internet is a wonderful resource, but you do have to cross-check. I've seen this attributed to, I don't know, Yogi Berra, Mark Twain, but it is Blaise Pascal, provincial letters, late 17th century, the original French, well, slightly updated. And it's really to do with the fact that we have a very poor relationship with time. Human beings are rubbish at it. Really, we have no idea. I mean, we mark time out, we chop things up into 24 hours, we have very, very, very precise definitions of seconds, we have ridiculous amounts of science around time. But we ourselves have a very poor relationship with it. We're very bad at assessing its meaning and its implication for ourselves and our work. So really, this is all about time. But there's another thing. People like to talk about value. As if that's some kind of absolute. Now, value, we really don't have much of an idea about it at all. I can tell you precisely how long a second is. There is an SI definition. But value, no, it doesn't come down to euros, it doesn't come down to anything easily measured. So, this is a quote from George Best. Late George Best, sadly. Northern Irish football player, rose to prominence in the late 60s, and 1970s. Very, well, sadly known for his drinking problem by the end of his life. But this is one of his classic quotes. I spent a lot of money on booze, birds, and fast cars. The rest I just squandered. There you go, that's a value system. The value system there is clearly not necessarily what everybody shares, but it does show you how people relate to things differently and how they prioritize things. This is a conversation. Yeah, we're coming up to the anniversary of this conversation. This guy, I can't get this code working. Did you check it before it went? Yes, checked it with the interpreter. Did it work there? No. Now, what this also indicates is not merely the pressure of time, so I'm trying to get something done, but it demonstrates, because this is a great deal of relationship of time, all of these things is about our psychology. This shows something deep within the human, deep within the program. It shows an unconditional sense of optimism. Well, you know, it didn't work there, but you know what? If I use it in a different environment, maybe, just maybe, things will align and it'll work out. Everyone in software development has such an optimism deep within them, even the pessimists, otherwise they wouldn't be doing it. Okay? There's this kind of idea, yeah, but it might just work out. You know, it's good, oh yeah. But we also have these kind of cultural, this is an old engineering saying, move fast to break things, popularised more recently by Facebook. And it's kind of got this kind of like high octane kind of aggressive push, just like, yeah, we're out to the frontier. We're just going to go for it. We don't care who stands in our way. The problem is the people who stand in your way are people. And it turns out that doesn't always work out so well. Both inside, as in the development, as well as outside the context. We have this obsession. It's a cultural obsession, and it's one that is distilled very finely in the technology sector. We have an obsession with speed. Now, I would say speed, except for the fact that a lot of people keep calling it velocity. And it's just like, we talk about velocity, we talk about sprint velocity. A lot of people think velocity is a Scrum idea. No, I first saw Ken Beck use it. It's in the original Extreme Programming book. Velocity was used there. Ken did not mean anything too deep by it. He was just reaching for metaphors. We all reach for metaphors. But we have turned this into a quasi-religion. The only problem is, in the religion versus science debate, I get very worried about this because I have a degree in physics somewhere in my past. And there's a big difference between velocity and speed. Velocity, I'm going to keep it simple and two-dimensional because it's Saturday morning, we can't have more dimensions. Velocity has a sense of direction. It can be resolved with respect to axes, it has different components. Speed is magnitude. Okay? Speed is how fast am I going? Velocity tells us direction. How fast are you going? You know, one of the things I like, so I get to travel all over the place, I get to drive in different countries. One of the things I really enjoy is going to Germany and driving on the Autobahn. Because there's no speed limit. It's not a velocity limit, let's be very clear. Speed limit. You are perfectly entitled to go in the wrong direction at great speed. As I once discovered when I was going like, yeah, this is good. I was heading out of the airport and then I realised the sun was in the wrong place. It turns out that, yeah, hell, I'm driving at 150 kilometers per hour. North. I should be going south. I would actually be making better progress if I were walking south. And this is the problem that we have. There is a sense of direction we have that is missing. Because actually we want that for our products. It's not really a case of like how fast are we going, oh wow, we are burning through the story points, we are doing this, we are doing that. And it's just like, yeah, but are we building the right thing in the right way? You know, are we racking up technical debt? Have we got misunderstandings? How's the team feeling about all of these things? And sometimes we have optimized the wrong thing. We end up optimizing, doing the wrong thing at incredible speed. And we measure that rather than the sense of direction. So, sticking with a slightly flatter magnitude thing, the speed is the magnitude of velocity. There's another way of looking at it. Yeah, you weren't expecting equations on Saturday morning, were you? That's the great thing about doing a keynote. You've got a captive audience. I can see when you It's the rate of change of S, displacement. It's the rate of change with time. What you're talking about is the difference of S over time. And this leads, and we can keep it simple and just, I'll bring it back to the kind of equations that my kids are learning at school. S. Now, what is S? S is supposed to be distance or displacement, but I'm going to use a technical term that will allow us to talk about this in the context of software. S stands for stuff. Okay, just stop me if I'm being too technical here. I'm inclined to do with the equations. Rate of change is stuff per time. Now the problem is the measurement of stuff. Okay, what is it that I can measure? And that's the problem. We run out and look at things that we can measure. Maybe it's lines of code, maybe it's components, maybe it's story points, maybe it's whatever it is. But there's this idea of stuff, and we look to measure things precisely because we live in an age of precision. And we go ahead and plot it. Stuff with respect to time. Burn down chart. Now, a lot of people read an awful lot into these. Burn down's pretty good, although it turns out that the reason it's called burn down, as I understand it, is because Jeff Sutherland used to be a Phantom jet fighter pilot, and that is the name for the profile as you approach an aircraft carrier. It's the burn down. There's nothing deeper than that. It turns out it matters an awful lot. You don't want to miss the aircraft carrier. It's quite expensive. So your burn down is really important. Now, this is how much stuff have I got left to do over time. There's another one, which goes the other way. Sometimes people call this a burn-up chart, because it's the opposite of burn down. I don't think it's opposite enough. I've always called these build-up charts. There's a very simple reason I don't like the term burn-up. One, I'm an enthusiast, I'm a space enthusiast, so the idea of things burning up is generally considered to be a bad thing when you're returning to Earth. This is a not good thing. The other thing is I'm also a father, and anybody who's ever had to deal with a child with a fever will know that burning up is also not a great thing. So build-up is quite literally more constructive. This one shows us something different. How much stuff do we have with respect to time? And we're building up. There's your incremental. People idealize these as straight lines, and you often find straight lines are given this optimal view. And we can project both and mess about with these things and end up calling it a cumulative flow diagram and get lots of different points of view. This is all good, but we have to be very careful about the stuff that we are measuring. T is, let's do a bit of dimensional analysis. T is measured in time. T is a time thing. Let's go back to the measurement of stuff. How do we measure stuff? This is where it gets hard. How do you measure functionality? It's quite difficult. So we often end up with proxy concepts. One of the things we end up doing is we will say, and there was a phrase in the Scrum community just about over 10 years ago, where the idea was you talked about the number of hours estimated that you had left in your backlog. I remember visiting a company there and seeing, this is when the penny dropped, seeing their plot of hours against days. And I said, you do realise you're plotting time against time. Yeah. I've visited other teams who sort of say, oh, we don't fall for that, we use story points, and then they have a conversion, currency conversion to story points at a time. It's just like, yeah, you might miss the point here. Now, time against time, what does that measure? Well, one of the things it measures is utilisation. How much time am I spending per day on this? And the idealised view, your fantasy view of development is, I spend 100% of the time working on beautiful code. In practice now, and the more responsibilities you have within a team, it turns out that you find that your utilisation starts dropping. So this is a utilisation measure. So therefore it does measure something, it's just not anything to do with velocity. It's not even a measure of speed. Well, in what sense it is, I guess it's a measure of traffic congestion. The other thing it might measure is quality of estimation. Yeah. So, in other words, there are all these things it might be measuring, but the one thing that doesn't is velocity. So here's a notion. What we need to do is take a step back. I mentioned Phantom Jets and Air Force America, or US Navy. Boyd was a US Air Force pilot, and he made his observations that basically this approach that changed the way that people perceived combat situations. And what is interesting here is when you start thinking of things like fighter jets or the rest of it, the one thing that comes to your head is speed. And yet here's somebody who is advocating a completely different way of reading the situation. Observe, orient, decide, act. Ooh, that doesn't sound very good. No, it's dead. Yeah. Is it working now? Of course it is. This is technology. What was I thinking? Yeah. Okay. Look what he's doing. Observe. Let's just take stock of the situation. What do we see? Orient yourself. Where you're at, where you want to be. We're not here, we want to be there. He's not talking about speed, he's talking about position, he's talking about relative position, he's talking about reading the situation. Make a decision. Carry it out. And repeat. Now, if you look at this, most of this act is the only bit where you might act fast. Everything else is about not being fast. Everything else is actually about slowing down. Read the situation. Fools rush in where angels fear to tread. There's lots of sayings that we have embedded in different languages that give us this exact same idea. Slow down, take a look. Because it turns out the things that you miss are probably going to be more significant than the speed that you go at. Now, I'm going to flip this one through 180 degrees, just because I can. Actually, no, I'm going to flip this through 180 because coincidence here. It's when I was putting together a workshop with a friend, John Jagger, we were putting together a workshop. We had these various loops for refinement. I got the OODA loop from John, and I was going to advocate a different loop. And we said, which one? And it was at that point I noticed that if you twisted them, they matched up. This one, PDSA. The words are slightly different, act is in a slightly different place, has a different sense. Plan, do, study, act. This is the Derek Shewhart cycle. It has become popularised as PDCA, plan, do, check, act. I'm a bit more old school, I like plan, do, study, act. There's a number of reasons I like plan, do, study, act. It's because study sounds slower than check. If you think about check, it's like checking, yeah. So my oldest son had some exams just before summer. My wife and I encouraged him not to check his work, but to study his work. Yeah, study, slow down, take some time with it. If you look here, plan, do, study, we also have a slight problem here. People often repeat this but without realising the implications of it. And this is the key thing. Plan is a word that has so many different meanings we have to nail it down. Establish a hypothesis. Here's the thing that we believe. We've got this idea. That's great. It's lovely to have ideas. It's lovely to have beliefs. But what are you going to do about it? Well, here's how we're going to make it real. We're going to make it real. Do it. Now, because it's an idea, and ideas are very fluid, and the world is a very strange place, and software, the very act of building software brings understanding and recognition. The very act of putting software in the world changes the world. So therefore, don't just charge ahead. Don't just break things. Take a step back. Study. What happened? We'll be surprised by stuff. What is it that we've suddenly turned out to be good at? What are the things that maybe we need to spend a little more time on? What are the things that are outside our control? These are all good questions. It turns out that people are obsessed with answers when they should be obsessed with questions. You need to improve the quality of your questions. That requires you slowing down. The right questions will take you in the right direction. Yeah? The answers are not as important. And then act. Now the problem here is that there's a kind of a waterline running across the centre of this screen. Plan and do are above it, study and act are below. Planning and doing are actually quite visible activities with visible consequences that are immediate. I can see people planning. I can see the outcome of plans. It doesn't matter if these are old school, heavily pert diagrammed plans, or if they are stickies on a whiteboard. I can see the outcome of a plan very, very clearly. The doing I can also see. Although, to be honest, my kids are a bit disappointed that it turns out that software development is not quite as exciting as it's made out to be in films. You know, it's just like you don't always have people going like, yeah, hook me up to this and write a really dodgy code. They're getting good. You know, maybe I'm training my kids to get good at the wrong thing. But it's just like, yeah, Dad, they're never using JavaScript for that. You know, it's like, exactly. You know, or when we watched the original Jurassic Park, really? You're using Pascal on your Unix workstation? I don't think so. Stuff like that. And it's just like, yeah, they're hacking through CSS. That's not going to get very far. So, I have noticed films and TV series have been getting better in recent years because there's enough people who are nerdy enough, who are consultants, and also keep criticizing shows, saying, you know what, get some bash in there, people will take you seriously, or, it's just like, yeah, that's a DOS prompt. You might want something a little more credible, maybe bash at least, so stuff like that. So there's this kind of stuff, and you don't have kind of like industrial metal music pounding in the background, multiple screens, and a successful group of software developers looks like a bunch of people, is indistinguishable from a bunch of people looking at pictures of cats on the internet. Okay, it's just like, there's not a lot going on there. But we can still see the outcome. Okay, you can see code, you can see tests, you can see demos. Do is visible, or has much more visible artifacts. So plan and do are actually quite visible. And indeed, their failure mode, we find in phase development, plan, do. Okay, there's an awful lot of that. Basic, incremental development, plan, do. The bit, and a lot of people are saying they're doing Scrum, are just doing plan, do. Study and act bit are really hard. They're below the waterline, we can barely see them. What does a group of people studying and coming up with ideas look like? It's not as obvious. But that's the really important bit, because it's not as obvious, we can't point to it as easily. We devalue it. And yet it turns out to be the observe and orient aspects that we're so interested in. So it's like, because we are coming up to the 50th anniversary, which is tomorrow actually, the beginning of the NATO-sponsored software engineering conference. Last year I found myself sort of talking about this conference quite a lot because 1968 turned out to be quite a pivotal year, a key year for a lot of software development firms. And a lot of people sort of said, oh, well, all our troubles to do with project management, waterfall development, they'll come back to this software engineering idea and all the rest of it. You know what? This document is one of the most widely unread documents I know of. People love to cite it. But very few people read it, but thanks to the internet we can get our hands on it. So I had a read through, and it's really interesting. It shows diverse points of view. You've got a room full of people who have different points of view, but nonetheless, they do not all say, yes, we need total planning and all the rest of it. Nobody says engineering is like software engineering is like bridge building. All of these are myths. People come up with really crazy ideas like the design process is an iterative one, Now, we have a big question about what happened in the 1970s. I don't know, disco flares, who knows. But it turns out that this is not the only place in the document. It turns out there are a number of places where people are talking about this kind of cyclic approach. And we actually look back and see the hardware that these people were working with. It is quite astonishing how far ahead of the game some people were. And what they regarded as blindingly obvious by 1968. So, we always do this, it's terrible. The whole industry does this. We made note of it. Agility is ultimately the action, but there is a notion that it is not, in one sense, a new idea. Another observation, one of my favourite authors, Neil Gaiman, we need to recognise that the very act of developing software is a creative act as well. It is genuine, draws upon a lot of creativity. Sometimes people think, oh, I'm just a software developer, I'm not creative. It's just like, yeah, no, don't be constrained by the idea that to be creative you have to either draw pictures or write stories. Creativity is central to software development. You are creating fictitious executable universes. Okay? You are using your imagination to put things out there that simply do not exist in any other form. You know what? That's creativity. So if you have in your workplace of work the distinction between the creatives and the devs, change your language. Okay? It's a subset relationship, it's not mutually exclusive. Developers are creative by definition. But the key point here that Neil Gaiman offers us, you have to finish things. That's what you learn from. You learn by finishing things. There's that idea of once something is logically complete, you're able to say, oh, yeah, there it is. Now I understand it. Oh, that wasn't so good. Well, that was good. So one of the things that I learned a great deal is I actually write short fiction. And one of the things about writing short fiction is you get to finish it a lot sooner than people writing novels. Now, one of the things that people, is often said, everyone has a novel inside them. Sometimes, quite frankly, that's where I should stay. But next month is known as National Novel Writing Month. So if you're interested, the goal is to write 50,000 words in November. Every single day, you write around 1,600 words. National Novel Writing Month. Apparently, within publishing circles, December and January are known as National Novel Rejection Months. But the point here is these people it takes a lot of effort to create a novel. The software system is not a novel. It's perhaps a fragmented novel. It's made up of lots of shorts, made up of lots of shorter things that can individually be refined and understood on their own terms. So I know lots of people who've never finished their novels in the time I've written lots of short stories, and I've learned a great deal by finishing each one. I've experimented with different writing styles, and that's the whole point. You experiment, you learn, you go, that didn't work out, or that's surprisingly good. The point is you get to a point where you can reckon much more quickly. If you're halfway through a novel, you're halfway through a novel, that's it. You may have learned a few things, but you do not yet know what the full experience is like. So we encourage people to break down their work. We encourage people to react. It's been said that writing is rewriting. But there's an interesting thing here. Martin's book, second edition is coming out this year. Improving the design of existing code. We like to talk about code, I like to talk about code. A very narrow view, though, when we talk about code. Sometimes you talk to developers and they have a very specific idea of code. If you talk to a Java developer, then their idea of code is Java. If you talk to a C# developer, their idea of code is C#. However, what you'll find is that in any given system, most systems these days involve more than one language. I'm a Java developer. Oh, you guys do web front end? Yeah, that's a JavaScript. Are you involved in that? Yes. Still a Java developer. I mean, I can understand that. JavaScript comes with social stigma. Yeah, fine, I get it. But there's the notion there that that is also code. Your tests are also code. Your scripts are also code. All that wretched stuff with angle brackets that is apparently human readable, but for a very small class of human, I reckon. That is all code as well. These are all code. All of this stuff, all of these artifacts are code. They deserve your care and attention. And curiously enough, what they do is they represent codified knowledge. So yeah, I'm playing with words here, but why not? Code means many things. Sometimes when we say code, we mean something that is incomprehensible. Something is written in code. Yeah? That's not a good thing. And a lot of code is written in code. Which is a problem, because this is what's going on. This is, people often talk about knowledge work, but it is a codified knowledge base. That is what your code base is. We often strike many different metaphors for what is our code base. But there is this idea, it's codified knowledge. These are the things, as we collectively, as a team, over time have understood how to build and what to build. The question to answer for our client, the architecture. Now, what does that mean if we are trying to acquire and articulate knowledge in codified form, very precise form? What does that mean for development processes? Well, by definition, the development process is a knowledge acquisition process. Okay? Now that's kind of interesting because that tells you that the development process is not a manufacturing process, it's not a production process. And words like productivity are misleading, as well as perhaps a little dehumanizing. It is a knowledge acquisition process. Now, knowledge acquisition process sounds absolutely brilliant. I want you to put it on slides, particularly when you're showing it to people who are higher up in the organisation, because it sounds technical. The rest of us can get by with shorter words like learning. Yeah, but if you're trying to sell it to somebody else, so tell me about your development process. It's based on knowledge acquisition. You can add in extra words. We've got a knowledge acquisition potential model. Wow. Yeah, I'm right into that. What do we do? We're learning. What do learning processes look like? Well, they're a little bit messy, with regions of structure. They're cumulative. They're revisionist. As you learn things, you learn new ways of seeing the things you already know. You build up your knowledge. You appreciate the things that you do not know. You appreciate the things that you figure out. You're going to have to find out about something. You prioritize the things you think, you know what, I'm not going to learn about that, or I'm not going to give as much time to that. So learning processes have this kind of quality that we want. So therefore, our development process should look like a learning process. Now, what is the propagation of knowledge? How do we get that around to people? Well, we call that communication. To be quite honest, these days I can see there's an awful lot of communication that doesn't transfer knowledge. There is an idea that in successful software development, we are communicating. And that means through the code, face to face, through whatever artifacts we're doing. Do my tests communicate? How good are my scripts? If I regard my scripts as second-class citizens, they're probably not very good. That's probably going to slow me down, but not the right kind of slowing down. It's going to slow me down in the sense of traffic slowing me down, rather than the sense of I am looking around and trying to take stock of everything. So there is this idea that all of these are acts of communication. So I often tell people, writing a test is not checking that something is right. Writing a test is an act of communication about here's something that I believe I understand and I believe I want. I could be wrong, but I made it so visible that you can come in and say, yeah, or no, there's a slight refinement here. That's what you're trying to do. And you want that with your code, you want that with anything in the development process. Which also tells you, wait a minute, this is about other people. So, communicate, we don't just communicate with ourselves, we communicate with other people. So what is your code base then? It's not just codified knowledge, it's social negotiation. Most of our stuff about coding guidelines and all of these practices, all of these things are actually about how do people get on? How do you get a bunch of people together and get them to work together with knowledge? You're creating basically a model of participation. That is what an architecture is. A software architecture is many things, but one of the things that is most often overlooked, it is a model of participation. It is how we have chosen to work together. And it tells you, just as it, sometimes we overuse metaphors, sometimes we don't use them enough. And when you look at a building architecture is the organization's space to achieve some kind of purpose. And you're trying to get people together, then have something that gets them together rather than pulls them apart. How do I get people comfortably working within a space where they feel that they can participate? So, I was asked this question, year or two ago. What is the biggest advantage of autonomously working teams? And I said, well, it's risk reduction through increased group intelligence. That's not risk elimination. I can't tell you that you will never have problems. I can't tell you that doing any of these practices will cause you to never have problems. What you've just done is you've reduced the probability of your exposure to those problems. But there's an interesting idea. What you're trying to do with this knowledge, this communication, this connection, is increase group intelligence. Group intelligence is a very interesting thing. This observation, there's little correlation between a group's collective intelligence and the IQs of its individual members. Okay? In Britain, we call this a referendum. But if a group includes more women, its collective intelligence rises. You're not bad. You could be smarter though. But there's an interesting point here. Why might this be the case? So it's just a change of communication styles. This is a number of other observations why diverse teams are smarter. People from diverse backgrounds might actually alter the behaviour of a group's social majority in ways that lead to improved and more accurate group thinking. Just because you've got a group of people does not mean that they're automatically smart. You've got to think, well, what is it that they are communicating? How are they communicating? What you've got is an opportunity. But the opportunity doesn't mean called magic happens. We've got lots of smart people together. diverse teams are more likely to constantly re-examine facts and main objective. Communication style doesn't mean that it's all happy moments. Somebody saying, oh yeah, but I was on this team, we were really great, we were really diverse, but we were always arguing. I'm not talking about getting toxic people in. But as I said to this person, like, you're arguing, is it bad? Or is it, oh, no, we just, sometimes there were things we couldn't agree on, and all the rest of it, and everybody went to the pub, and that was all good. So in other words, what you've got there is just the right level of interaction. If you're recruiting, and this is the danger, we end up often recruiting in our own image. I visited a company a number of years ago to try and help them improve their skills. I was visiting kind of once a month for just a day over a period of months. And this was a company that was a financial trading company. Do you know what was really interesting? All the people I met on this team were games programs. Games programs, Boston, City, London, on an adventure in code. So wait a minute, you're all games programs. How did that happen? It happened because the person who set up their department came from the games industry, and he recruited in his own image. So what you had is, guess what? White, male developers who were technically very good, had a habit of making stuff up, and doing some very crazy things with code. And yes, certainly they were technically good, but they were drawn from a very narrow demographic. And that's potentially incredibly brittle. If you're all thinking the same, you're all not thinking. You need people of different ages, different ethnic origins. You need people who are not going to end up thinking the same. You don't want everybody who's graduated in the same degree either. I dealt with one company, and that's what they recruited from. Same degree, same demographic. Oh, right, so more young guys from Northern England who are in their early 20s and came from one of 3 universities in the north of England, and all graduated in computer science. That's an incredibly narrow set of thinking that you draw from. So there is if we're trying to engage in an act of intelligence and knowledge, then engage in an act of intelligence and knowledge. As I said before, this stuff doesn't come for free. James Surowiecki, 2003, Wisdom Crowds, he gave us some basic conditions. We could tinker with this, but he gave us the basic 4 ideas that you can mess around with. This idea of like, yeah, you want to have a group of people not be stupid, then here's a head start. Diversity of opinion, independence, decentralization, and aggregation. Independence is that they are not necessarily influencing one another. That's actually sometimes quite difficult. Decentralization, they are drawing on different sources of knowledge. But the most important thing is the last bit. It doesn't matter if you've got people heading off in different directions, if you can't get them back in the same place to congregate. Aggregation. That's the important thing, ultimately. How do we do this? And that's meetings by the coffee machine, that's code bases. Code base is an aggregation. Okay, there are all of these things that represent where we come together. So, this gives you an opposite sense of relative speed. But there's another thing, we're also obsessed with these physical ideas. Speed, the other one we're obsessed with is size. You might say, well, what do you mean we're obsessed with size? How often have you encountered the word scale in the last few years? I don't remember people talking about using the word scale very much 10 years ago. 20 years ago, people really, scale only existed as something you talked about in the context of distributed systems. It was a runtime thing. It was not how we organize our teams. But these days, everybody's talking about scaling agile development. And there's a curious thing. Words are funny things. Scale has an implied meaning. And I think it's good to challenge that implied meaning. When somebody asks you, yeah, we need to scale this development, ask them, do you mean up or down? It's hidden in plain sight. Because sometimes I agree, yes, you do need to scale this. But taking yeah, it's not working out. So let's scale it. Do you remember that quote I showed at the beginning of the talk about, hey, this doesn't work. It doesn't even work when I tried it in the small. That's not just somebody sitting there with Python, as that was. That's also the way we treat teams. You know what, this isn't working out. Yeah, let's scale it. Now you might think I'm just playing with words. In one sense you're right, but it turns out that cultures often adopt words without questioning. So I have a counterpoint. My older son has been doing well, he's not doing quite as much now, but for a couple of years he was doing a lot of CrossFit. And CrossFit is a kind of it's a kind of physical training regime, strong emphasis on weights. So it's interesting because in the CrossFit community, the word scale is used, and it means exactly the opposite. It means scale down. When you scale an activity, it's because perhaps you're new to it, you're not strong enough or fit enough to be able to do it, or perhaps you've got an injury, which means you can't do the full one. So you scale it, so you're able to do the reps, the repetitions, but slightly more easily. So to scale means to scale down, not to scale up. And you hear it in conversation with CrossFitters. I've heard it with him when I picked him up in the car. So I had to go, oh yeah, a couple of new ones, I had to scale them. It doesn't say scale down, it's scale. So I want you to challenge that assumption. And there's this whole idea, we start talking about, well, I always like the idea that we like to emphasise craft, so here's some craft. Software development does not have economies of scale. Observation from Alan Kelly. We've also grown used to these manufacturing and production metaphors. Software development does not have economies of scale. Development has diseconomies of scale. It's an intellectual activity, so therefore it's very much about the shape of communication between people. And that is not quite like organising pins or manufacturing cars. So here's a simple thought experiment. Oh my God, you're going, what? More equations? Yeah. I'll start with an easy one. We can just do this as a thought experiment. T equals T1, fine. Okay, what's that? That's the time taken for one person to complete all the activities involved in some aspect of software, in delivery of something, creation and delivery. There's testing, they're doing it. There's talking to the customer, they're doing it. Coding, yeah, all the rest of it. One person, this is how long it takes them. And then we get all Adam Smith about it, we go, hey, I've got a great idea. It's division of labour. We're going to 8 people. We'll have 2 people, it'll be twice as fast. 3 people, 3 times as fast. 4 people, we're breaking the sound barrier. Oh, well, slow down. Yeah, the real world is a little bit messier. P, proportion, in parallel. Yeah, there might be wait states. Are we waiting on anybody? Yeah, so it turns out, the lean guys were right. This kind of idea of waiting states and work in progress, these things matter. If you're waiting on everybody, everybody's waiting on. I think the shape of your process causes these intermediate states. You're not able to flow. There's a lot of stop-start, then you can reduce the effective concurrency of all of these people so that everybody behaves as if there's actually not n people. Curiously enough, we do actually know this. It's called Campbell's law, but we normally talk about it in terms of processes, which also allows me to clarify this is no more than a thought experiment. Don't come up and measure the curve and the equation too precisely. It's just a rough idea. What if programs were interchangeable? We don't know. But we're not done yet. It gets messier. By the way, you can keep doing this and adding more terms, but this gets us messy enough. Worst case. What is the worst case? Everybody talks to everybody else. Everybody's communicating with everybody else. That's talking, that's meetings, that's code bases. We are interfering with other people's work. And while what happens is that we create our own little areas. We defend against other people in many cases. The worst case, so this is a consequence of architecture and practices. Communication overhead there. The worst case scenario is we are treading on everybody's toes. And, just in case the equations are too much, hey, there's a beautiful curve. Look, T, F, N. So if we have no people, intuitively enough, it takes an infinite amount of time. Okay? That's satisfying because at least there are no bug reports. And then we start adding people, we start speeding up. And then there comes a point when we start adding people and start slowing down. So this is slightly different to Brooks's law, where we were talking about adding people to a late project, making it later, although it is indeed related. But what we find is a gradual slowdown. Now, it turns out that if you want to speed up these projects, sometimes you have to take people off. I have been fortunate enough, early in my career, there was somebody who actually did that, and halved the size of a team, and brought them back on schedule from a 6-month delay. So I was very lucky to see that in action. And Richard was he was a classic servant leader, I now recognise. He was really good. He was just trying to figure out stuff. He spent an awful lot of time thinking and trying to reflect on stuff. He didn't look like he was working, but stuff was happening. He was trying to remove the obstacles. He was great, so they fired him. Because he made all the other managers, he made all the other managers look bad. So it was a simple case of that. So we have this. Now, obviously, if it were beautiful and smooth, and sadly, as I said, this is just a thought experiment, the real world is messy. It's foggy. There's ups and downs. Sometimes you can't tell if you've reduced or added a person, if that's speeded things up or not. But there is a general notion that this is a question that deserves to be explored. The only way you can change these things is by changing the skill level or changing the scope. So this is why you want to have good people. And good people is not just an individual set of good persons, it is the group intelligence. You want to increase group intelligence so that you're able to act more effectively. Now the problem is we're really bad at learning from our mistakes. So we often end up pushing ourselves out here. A lot of consultancies operate with big N. Also, the thing is about learning from our difficulties. We end up with saying things like, oh, well, we had that really big project a few years, lasted a few years. We had 60 people on that. We've got another thing that's about the same. 60 people didn't seem to work out, so we're going to do the same kind of scale of thing. We're going to do it with 80 this time. No. Try 40. Maybe try 20. Be wild. Try really small and then grow it slowly, and then notice when you slow down. That is the easiest way to find out where this curve ends. Okay? Start small, add, and then watch out. See what happens. Observe. Okay? This is all about slowing down and checking out what's actually going on. But there's another thing to this. What this actually says, what this tells us, and we have data, we have anecdata as well to back this up. This idea that the real problem here is that we make our systems too large and too complex. It becomes a self-fulfilling prophecy. This is an interesting one, because people often think, well, the amount of effort, the scale of the software architecture, the number of lines of code, all of this is in proportion in some way. This is in proportion to the scale of the functionality. Oh, this system has lots of functionalities, we get lots of people. You know what? These actually, after a certain point, they decouple. And it raises a different question. So this is from a couple of years ago. But it's still quite a simple observation. Facebook iOS app has over 18,000 Objective-C classes. In a single week, over 400 people contribute to it. Now, here's an interesting thought. I mean, leaving aside the fact that I have no idea what those are doing, sometimes people say, oh, well, that's fine because they're doing lots of analytical stuff. No, that's actually on the back end. Sometimes people say, oh, that's fine because some of that's code generated. As if that's a good thing. Honestly, if people wrote scripts to produce crap, I might question the value of the scripts. But there's another thing here, and this is the deeper question. Let's invert the question. How could you produce something small with over 400 people? I don't think you can. If I set the whole room, all of us here, and we decided to build Hello World, I think we could make the most magnificent enterprise monstrosity. Really, that's too many people. I don't think it's possible to create something that is an appropriate size. Okay? I think we will miss the concept of the appropriate scale. I think it's not possible. I think the challenge that we've accidentally overlooked is this one of not just how do we build it, but how do we build it. In other words, the how includes the people. And how many people. And how smart do we want their collective to be? And that's a very different question to the way that we often answer this. And we end up building things at scale. Since I know certain Mr. Evans is in the audience, I thought I'd use a quote, one of my favourite quotes from him. Here it is, yeah. Your customers do not buy your software by the line. Of course, if they do, ignore everything I've said. And well done you for getting that contract. That's what you use code generation for. So how do we go about this? How do we start thinking about these things and sort of bringing this one in? There is this interesting question of breaking larger interconnected things into smaller groupings. Christopher Alexander, 1964, he's the patterns guy. This predates work on patterns. We may therefore picture the process of form making as the action of a series of subsystems, all interlinked yet sufficiently free of one another to adjust independently in a feasible amount of time. This is kind of interesting because he's talking about stuff that we've been chasing for decades. And he's talking about systems in general, he's not talking specifically about software systems or buildings. It works because the cycles of correction and recorrection which occur during adaptation are restricted to one subsystem at a time. That's kind of an interesting way of looking at it. Localizing things. It turns out the reason we care about software architecture and coupling and all these kinds of things is humans. It's not actually we're processing variables. It's how we work together. It also turns out that everybody in the 60s was really keen on drawing bubble diagrams and things like that. This is from the original Melbourne Conway paper. Where Conway's law came from. The basic thesis is organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. We often quote that bit, but then they forget the next bit. We've seen this fact has important implications. Oh, people don't like implications, just show me the fact. No, for system design, the design effort should be organized according to the need for communication. That's provocative. Now, clearly we know an awful lot more than was known back then. But nonetheless, there's a really interesting question here that deserves to be followed up. Now, when people talk about law, we have to be a little careful. Laws can be quite aggressive, but sometimes I hear people say, "Oh, we don't believe in Conway's law, or we defy Conway's law, or we're using this process and it negates Conway's law and eliminates it." No, that's not true. Let's understand the four-force diagram of flight. It's a standard diagram for flight. It's balancing forces. There is gravity, there is lift, there is thrust, there is drag. The reason I put this one up here is to show you there's an interlinked set of forces, but also, when you get on an aircraft, you do not defy gravity. When you are flying, you have not negated gravity. Really, you are playing with it, or rather, it could be playing with you. Okay, you have not suddenly magically invented anti-gravity. You have not nullified the gravitational field of the Earth. I mean, when you do that, well done, and I'm going to be on your spacecraft. But the point here is that is not what is happening. There is a careful balance between these. Now, I don't want to overwork it, but we can imagine that there are similar things here. We've got the design effort, but that can be held back by debt. The design effort and our practices can give us lift, the form of the craft. And Conway's is always there. The fact that the way that people communicate will influence the way that you work. To say that the way that people communicate does not influence the thing you create is an astonishing statement. But there is a careful interaction between these. Which allows me to, yes, it's equation time again. I'm going to really stretch the physics metaphors here. F equals ma. Force, mass, inertial mass times acceleration. So here's an interesting thing, inertial mass. That's kind of like the stuff that holds you back. It's the amount of stuff you have to deal with. It's the amount of code stuff and architecture stuff and infrastructure stuff. It's the stuff you have to work on. A is for acceleration, or maybe A is for agility. Now here's the interesting thing. If you put a lot of force into something that resists it, you don't get much agility. So it tells you that the shape of the artifact is not just enough to have an agile mindset. That mindset, the way that you work, has to be reflected in the artifact that we're working on. Because otherwise you're going to end up with M is for monolith. One stone. One very big stone. And this is going to slow you down. So there is this notion that the architecture tells you something about the way that you respond. You cannot just be agile in your head and in your team practices. It has to be reflected in the artifacts that you're working on. It's a much deeper picture. So I'm going to return to this question in closing of speed. Many years ago I came across this saying, mid-late 90s, in an interview with an entrepreneur. And I found it a wonderfully provocative question, because it has a simple and obvious answer that is correct. Why not? Cars have brakes. Why not cars have brakes and you can slow down? The answer is simple and obvious and correct. But it is not the full answer, because we have a poor relationship with time. We have not seeing the full scale and consequences of what this means. This is what it means. Cars have brakes so you can go faster. Simple thought experiment. How fast would you go if somebody said, hey, nice car, would you like to take it for a drive? But the brakes don't work. No, I'm good, thanks. And yeah, people do. And it's an incredibly dangerous task. It's an incredibly dangerous undertaking that they do. You're quite literally out of control. You can't easily change direction, or you have to, you have to improvise, as a friend of mine did. I do not know if he's still alive, but nonetheless, he drove a car without brakes for quite some distance, and he had to use careful touches of the handbrake, gear changes, hills, avoiding main roads. It took about 2 or 3 times as long to get where he was going. This is not the best way to drive. That's why we have brakes. Just have a reminder. When people are talking about speed, you need to take a step back. And with any luck, all of this has inspired you, perhaps made you smile.